Hello, welcome back. We're going to be talking about yeast-derived flavors today. So, a little bit of background. I'm sure you've had this already in one of your previous classes, but brewer's yeast, ale yeast is the Saccharomyces cerevisiae, lager yeast, Saccharomyces pastorianus, and some funky yeast are different species of Brettanomyces, commonly lumped together under the name bread. Here is a picture of our Hefeweizen yeast here at Henderson Brewing Company. Take it through our microscope. It's always fun to have. So, basics on yeast metabolism. They intake simple sugars. They can only ferment monosaccharides, disaccharides, and some trisaccharides. So the monosaccharides, glucose, dextrose, and fructose. Disaccharides like sucrose and maltose, and then the trisaccharide or oligosaccharide maltotriose. Anything, any sugar longer chain than that, they cannot ferment, and in the finished beer contribute to body, commonly known as dextrins as well. So obviously a conversion of sugars to ethanol, byproducts, intermediaries, and carbon dioxide. There are many compounds produced during fermentation that affect flavor and aroma. Beyond measure almost. There are so many. So we have here a basic overview of, a very basic overview of yeast metabolism, and we'll refer back to this so we can see in general the compounds that we talk about, where they kind of are involved in their metabolic pathway. So yeast products in general, you have alcohols, more than just ethanol, unfortunately, glycerol, esters, sulfur compounds, carbonyl compounds, and vicinal diketones. It's not exactly an all-inclusive list. These are just the most common ones that we need to talk about. So obviously alcohol, that is the desired outcome. That is the whole point of all this, yes? So the desired product of fermentation is ethanol. It's perceived on our palate as slightly sweet, warming, and it can be harsh in higher concentrations. And I think like vodka, it can take your breath away. You know, if that's your thing, it might not. Higher order alcohols, also known as fusel alcohols or fusel oil, butanol, propanol or isopropanol or isopropyl alcohol, 2-methyl-1-butanol, and isopentanol, also known as isoamyl alcohol. These can be perceived as hot, harsh, or solvent-like. Sometimes medicine as well, but those are the main descriptors: hot, harsh, and solvent. And we come back to this, and of course, everything that we're concerned about, we want ethanol. That is our desired effect. That is our desired outcome. That's what makes this drink so wonderful. And glycerol is produced in smaller proportion. Like a 5% beer has about 0.2% volume per volume of glycerol. It does contribute overall to the perceived sweetness of your beer. In theory, it could potentially aid in extraction of hop oils. Sometimes hop extracts are made with a 5% glycerol solution. As previously stated, 0.2% possibly could aid in extraction of hop oils, but it's such a low concentration, likely it's not going to really make that much of a difference. But it definitely does contribute to the overall sweetness of the beer in general. So esters, beer can contain upwards of 100 different esters. And we're really just touching the surface on the research on exactly what contributes flavor compounds in beer and what's produced by yeast. If you think about it, it's a live organism. You know, it can produce anything in the gamut as far as what are intermediaries and byproducts of its metabolism. what we're main flavor contributors that we're worried about is ethyl acetate. It's got a lightly fruity or somewhat solvent-like taste. Isoamyl acetate, which is that characteristic banana flavor that's produced with Hefeweizen yeasts. Isobutyl acetate is kind of fruity. 2-phenylethyl acetate, which is roses or honey. You get something that's really smells like a rose. It can either be phenol or it can also be 2-phenylethyl acetate. Ethyl caproate, which is apple. The other very strong apple flavor compound is acetaldehyde, and we'll get to that as well. And ethyl butyrate, which is characteristically pineapple. So sometimes that one is very desired. So different strains of yeast produce different amounts of esters. Ale yeasts tend to produce more at normal fermentation temperatures. Lager yeasts produce less at normal fermentation temperatures, but if they were fermented at like ale temperatures, it could produce equal amounts, if not more amounts of esters as ale yeasts. Obviously, you wouldn't want that in a lager because characteristically you want a very clean taste. Different styles allow for varying levels of esters to be acceptable. So English pale ales, for example, typically that's going to be a strong characteristic of any of their flavor descriptors. On the flip side of that, American light lager, esters should not be in that finished product. It's going to be a mess if you've got esters in an American light lager. It's going to be a fruity mess. Ester production or suppression is a field of study in the brewery world, and a field of study that has a lot of money thrown at it. There are many variables that can affect ester production. Temperature being a very important one, and one that we can control significantly, one that should be controlled significantly. The original gravity of wort. High gravity worts tend to lead to a disproportionate amounts of ethyl acetate and isoamyl acetate produced. So if you have a very high gravity wort, that is typically going to cause a stressed fermentation, which can lead to undesirable esters produced, or desirable if that's your intention. So just make sure you take that into account if you have a high gravity beer. You need to plan for a potential stressful fermentation and make adjustments in your process and your additions as well. Yeast health, good pitch of healthy yeast will produce a clean beer if desired. A underpitching can produce some esters, and yeast that is stressed or maybe not in best of health can also produce esters, and possibly not in the most desired way. Fermentation vessel geometry. So what the industry has kind of settled on are these very large cylindro-conical fermentation vessels. You got this large column, and it comes down to a cone basically at the bottom. That particular geometry has been found with very tall fermenters that can actually suppress the formation of esters from the weight of the beer on the yeast itself. And that is another way that you can suppress ester formation. Head pressure as well. Fermentation that is basically capped and maintained at a certain pressure can also produce lower esters. So there has been some people that produce a clean beer at a higher temperature by fermenting under pressure. I've not tried it. I don't know if I would recommend it because I don't know if I have had a beer that has been produced in that manner. It's possible. It's under research. I'm sure a lot of people are doing it with great results. Yeast strain. Different yeast strains can produce very different amounts of esters. When you think about all the ale yeasts are technically Saccharomyces cerevisiae, but within that you have multiple different strains that, like a Hefeweizen yeast, produces very distinct isoamyl acetate, very distinct banana. Technically genetically the same as American ale yeast that produces a very clean fermentation, very low esters. So dissolved oxygen and fatty acids can also play a role in general, and that kind of circles back to healthy yeast, healthy fermentation as well. Because during that lag phase of yeast growth, they got to have that oxygen in the wort to be able to create fatty acids. They also need a source of fatty acids as well. And we circle back to, I lost myself over here. We can see esters down here as basically a byproduct from the fermentation process, going from acetaldehyde to acetic acid, acetyl-CoA, which is a coenzyme factor, a fatty acid CoA, and that's cleaved and it becomes an ester. Significant production potential. Very important part of yeast metabolism as well. Sulfur compounds are very important. Number one, because of their very low threshold for affecting aroma and flavor in beer. Humans have a very low threshold for sulfur compounds in general because usually they're associated with rotten or spoiling food. So like hydrogen sulfide has got a rotten egg or just a general egg flavor in general. DMS, sulfur dioxide, and thiols rounds out our list here. So hydrogen sulfide, like I said, has a characteristic odor of eggs, rotten eggs. I haven't seen the rotten egg variation all that much myself, but I have had a number of yeasts throw off a lot of egg in general. And generally that goes away. It's a very highly volatile chemical. It will eventually, should, leave your beer. And if not, you could do some CO2 scrubbing to really push it out. That also pushes out some desirable flavor and aroma compounds as well. But excessive concentrations of hydrogen sulfide can be a sign of poorly managed or stressed fermentations. Sometimes it's just the yeast. There are certain yeasts that just throw off a lot of hydrogen sulfide, and it's just something you have to deal with and something that will go away. More so in general, lager yeasts throw off a lot of sulfur, a lot of hydrogen sulfide. Then a lot more so than ale yeasts. DMS, or dimethyl sulfide, has an aroma of cabbage, vegetal, cooked corn, just not desirable in a beer by any means. So it is produced from a precursor of SMS, or S-methylmethionine, which is a natural occurring chemical compound in barley, and DMSO, dimethyl sulfoxide, also natural compound that occurs in barley naturally through the kilning process and just in general. Particularly, both of those are in higher concentrations in lightly kilned malts, because the lower temperatures of these kilns don't drive off those precursors nearly as much as the higher kilned. So like Pilsner malt is going to have a much higher rate of having these precursors in there, and a much higher potential rate for having DMS in your finished beer. So if you prevent that precursor from being in your wort, it helps prevent the final product of having DMS. And the best way to do that is by rigorous boiling. You want either a rigorous boil, a longer boil, or both, a long, rigorous boil. So you want a good roll boil, you don't want it simmering. Next we have sulfur dioxide. It smells very characteristically of struck matches. So you strike a match, that smell that you get initially, that's basically sulfur dioxide, and that's the smell you're going to get if your yeast produces that during fermentation. Usually present in beer well below the flavor threshold, so it's just going to be an aroma that's thrown off. If it's present, you can drive it off with CO2 scrubbing. Likely it'll be driven off on its own, just because it's very volatile, it will evaporate. Then we get to thiols, and also known as mercaptans. And this is an area of a lot of research deriving from hops as well. But I've listed it under yeast-derived flavors as well, because even though, yes, they are derived from hops, it requires yeast metabolism to cleave those thiols from the hop compounds to make them into the final beer, to make them flavor active. So what we've got here, 4-MMP, 4-MSP, 3-MH, 3-MHA. Those are just abbreviations for long chemical names, but just know that thiols in general, they're going to be very low flavor and aroma threshold, and like I said here, in the range of parts per trillion, which is extremely small. So very tiny amount makes a huge potential contribution to the overall flavor and aroma of your beer. And these in general are very good aromas, very fruity. Most of them, like I said, are derived from hop oils, but they have to be freed by yeast metabolism, which is a lot of research we're seeing with the juicy or New England IPAs with fermentation, dry hopping. That's where you're going to get a lot of these intensely fruity aromas. So, like I said before, people have a very low threshold for sensing, smelling, and tasting sulfur compounds because they're usually attributed with bad or tainted or spoiling food, which is something that obviously we don't want to eat, so we're sensitive to those particular smells and aromas. Women are particularly more sensitive, even more so pregnant women. So if you're wondering if your beer has sulfur compounds, bring it to the lady of the brewery or your wife or significant other, and they'll be able to tell you whether or not you've done well. I usually let my wife smell my beer, and she'll tell me whether or not she smells eggs because she hates it. And when she was pregnant, I could open up a beer, and across the room she would tell me, ugh, that's not very good. I smell eggs. So carbonyl compounds have a very high potential flavor impact. There is a significant influence on flavor stability, and we'll see that specifically one particular compound in general. Excessive carbonyl compounds can cause a stale flavor in beer. Acetaldehyde is the most common of this class of chemicals, and it is found in the highest concentration. And part of that is because it's one of the main intermediaries in ethanol production. As you can see here, it's really the main step in between sugar and ethanol. You get a lot of acetaldehyde. So it's a significant byproduct in the formation of alcohol, and it's usually reabsorbed by the yeast after very active fermentation. The yeast cleans up after itself, picks up all that acetaldehyde, finishes it off into alcohol, reduces it into other non-flavor active compounds. But sometimes that's not the case. If you have a fermentation that's stressed or yeast that's not very healthy, they just can't reuptake that acetaldehyde, and that stays in the finished beer, and it tastes like green apples or sour apples. That is a sign of stress fermentation. It can also just be a sign of what's called green beer. It's too young to be tasted, and the yeast hasn't had time to reabsorb that acetaldehyde and finish cleaning up after itself, basically. So when you hear the term green beer, that just means it's not done fermenting, it's not done conditioning. Grassy aromas, propanol, 2-methylbutanol, pentanol, and as you can see, as opposed to alcohols, which end in OL, aldehydes end in AL. Sometimes the pronunciation can get a little hairy. They can cause a significant off flavor, specifically when it's coming to staling issues. So trans-2-nonenal is the compound that causes that paper, wet cardboard, stale taste of beer. It's formed through an oxidation reaction post-fermentation. So if you have oxidation ingress post-fermentation, either through transferring or through packaging, the potential exists to stale your beer significantly if you have oxygen in solution post-fermentation. And that's the most common cause of issues with staling of beer. And I have had a cardboard bomb from a very large nation, worldwide brewery. It happens to everybody. It just can happen. It's not an issue. You want it to minimize it as much as possible, but just know that if it happens, you're not the only one. Very, very well experienced, very good professional brewers have had this thing happen. It just happens. And then vicinal diketones. It's a very, most common one is going to be diacetyl, and also known as 2,3-butane-diol. That's where your common off flavor of butter, butterscotch, or toffee comes from. And it is going to be, if it's present, it's going to be very prominent. You're going to know. It's going to taste like movie theater popcorn. It's going to taste like a Werther's original butterscotch. It's got a very distinct flavor. And it also can affect mouthfeel, and it can make it feel kind of thick or ropey or slick on the tongue. So if you're tasting a beer and it tastes slick, or it feels slick, or it kind of feels like ropey, kind of mucusy, and it's kind of a gross way to describe it, but it's thick, it's ropey, that's going to be caused from diacetyl. And it's produced from the precursor 2,3-butane-diol, which is an intermediate of production of the amino acid valine. So I have seen some ways of alleviating diacetyl by dosing the wort with valine. That way that intermediary isn't necessary because the yeast has enough valine. I've also seen dosing with enzyme that breaks down that particular vicinal diketone into non-flavor active compounds. Best way is just to prevent the formation by having a healthy fermentation and or a diacetyl rest towards the end of fermentation, which lets you warm up the fermentation enough that makes the yeast active to reabsorb diacetyl or its precursor and break it down into non-flavor active compounds. This can happen, diacetyl production can happen in all yeast strains, either from just normal fermentation with lagers. It happens. It's a cold process. In general, it's produced. That's why you bring it up to temperature towards the end of fermentation and let it reabsorb all that and process it. It can also happen in ale yeast as well, and it can be a sign of a stressed fermentation or unhealthy yeast. And the other one, the other vicinal diketone that we were concerned with is 2,3-pentane-diol. Not as important as diacetyl, but it is very similar in all aspects. So we've got some other yeast flavors as well. We've got autolysis, and that's just yeast cell death. So that's the yeast itself, the cell bursting open, either from age, stress, or osmotic pressure. And that can also be from the pressure of the beer above it. If you got a really tall cylindroconical fermenter, there's a lot of weight pushing down on that yeast. So it can be, like I said, age, stress, or pressure. Best way to prevent that is to have healthy yeast, healthy fermentation, and remove your yeast from your beer when it's finished aging if you have very large fermenters. If you don't have the largest fermenters, it's possible you can let your beer sit on the yeast for extended periods of time. Do so cautiously and make sure you're tasting at regular intervals to make sure you don't start developing these off flavors. And then you can also just get suspended yeast. So if you've got a yeast that just does not want to drop, it's going to taste yeasty. And there is no other flavor descriptor other than yeasty. It just tastes like yeast. Sometimes that's desirable in the style, like a Hefeweizen, but most times it's not. You really want to get that yeast out of there, either by using clarifying agents, filtering, or a spin it out, if you can afford to do that. And that flavor from autolysis is sometimes described as soapy. It tastes like soap or kind of meaty, a little bit of umami. But soap is going to be the most common descriptor, and that is because of the phospholipid bilayer, the cell membrane of the cell itself is very similar to soap compounds, so it tastes soapy. And this is a picture of one of our very vigorous fermentations. I believe it was our Imperial Stout. I've described fermentation as an extremely complex, violent, and messy process, and produces the most complex liquid on Earth. And I really love it. And this is part of the reason why we don't have our fermenters out within view of the public. That would turn off a lot of people. Stuff like that also is dependent upon the geometry of your fermenter. Our fermenters are a little squatter and not nearly as tall, so we don't have as much head space when we fill. So we do get some blowout on particularly vigorous fermentations. All right, thank you.